Welcome back to the second lesson of Module 5. As mentioned in the last lesson, we're now going to take a look at different types of parameters in FMOD. We'll then take a look at what their individual purpose is, how we might utilize them, as well as how we can go about interacting with them through our scripts. We're even going to look at how FMOD structures its API in order to better understand our relationship with it, as well as its relationship with Unity's API. Okay, so let's jump straight into things today and learn what those two different parameter types are. Now, the first is called a local parameter. All of the parameters we've created up until now have been local parameters. A local parameter is simply a parameter that can hold different values for each event and event instance it is used for. For example, both the teleporter event and the health crate event both use the trigger parameter. Whenever our scene starts, both instances of the trigger parameter are tied to each event and are set to 0. Now, whenever a player collects health from a health crate, that instance of the trigger parameter for that event is then set to 1. But that doesn't mean that it's then set to 1 for the teleporter event as well. That instance still remains at 0. This is actually something we can test in FMOD. If we tell our health crate event to play, we can then press the plus at the top to open up a new tab of our editor window. Now, this gives us access to all of the same events, but now we can play a second event at the same time to test it together with our health crate event. So in this new tab, let's now play our teleporter event. If I now go back to the health crate event and set the trigger parameter from 0 to 1, and then check back at the teleporter event, we can see that the trigger parameter still remains at 0 despite the fact I set it to 1 for the health crate event. So think of a local parameter in the same way that you would for an instance of an event. If we create a new instance of an event using a local parameter in our game, we're also creating a new instance of that parameter, which can be set independently from other instances. Now, a global parameter, on the other hand, is the complete opposite from a local one. A global parameter can only ever hold one value. We can still use it for multiple events, but all of the different instances of that parameter will share the same value for each event. Now, to demonstrate this, I've temporarily changed the trigger parameter from local to global. So just like last time, both events are playing at the same time, and both instances of the trigger parameter are currently set to 0. Now, watch what happens when I set the trigger parameter inside of the health crate event from 0 to 1. If we take a look at the teleporter event here, the trigger parameter here has also been set to 1. If you like, you can imagine that only one instance of a global parameter can ever be created, and each event using that parameter is sharing that instance of it. So whenever we set a value for that parameter, all events receive the same value. A global parameter not only shares its value amongst different events, but also different instances of the same event. That's why, to demonstrate global parameters today, we're going to be looking at the health parameter we created for the health crate event in Module 3's challenge video. Now, as we know, there can be multiple health crates scattered around each scene in our game. That means that each health crate needs its own instance of the health crate event we created for them. It also means that the trigger parameter needs to remain local so that there's an instance of it for each individual crate in each scene. If the player were to collect health at one of their health crates at the beginning of the level, we wouldn't want the rest of the health crates to trigger, causing their audio to soon finish playing. The only one we want to finish playing is the one that the player is interacting with. However, the health parameter, as we know, is simply measuring and copying the value of the player's health. Now, we know that there will only ever be one player in this game, meaning that there will only ever be one health bar or health variable to monitor. So therefore, it makes little sense then for each instance of the health parameter to be able to set their own individual value. Really, we only want one instance of the health parameter, just like how we only have one player in our game. This way, we don't have to set a value for an individual health parameter instance every time the player collects health, we can just update the one and only instance and still achieve the same effect. So what we'll be doing in today's lesson is not only changing the health parameter from local to global, but also changing the script we used to implement this event so that it can interact with our new global parameter. First things first, make sure you have your own health crate event like mine ready to go. Now, because we created this event during the challenge video of module 3, you may not have this event, or you may have your own that's designed slightly different to mine. So if that's the case, make sure to go and watch the video at the bottom of module 3's challenge time page, where I explain how you can set this up yourself. It's not too complicated of an event to create, so once you've finished, come back and join me here. Once that's done, or if you already have the same event ready, the next thing you'll want to do is right click on the parameter at the top of the page and select Edit Parameter. From here, we can easily change the parameter from local to global. And that's it, your parameter is now global. You can now go ahead and save your project and then build your banks for Unity to use. So now that we've changed the parameter from local to global, let's open our Unity project and take a look at how we go about implementing it. Okay, so let's find ourselves the health crate that we attached our FMOD script to in module 3. Now, just like with the event, I'd recommend you use the same script that I created in the original lesson. If you've created your own script, then you may be able to follow along depending on how much of the challenge you completed, but if you wish to, you can find a link to the original script I created underneath this lesson, which you can then copy and paste for yourself to use. From there, simply create a new script called f_healthcrate, paste the code into that script, and then attach it to the first crate you can find in the scene, or all of them if you like, making sure to then drag the component of that script up until it is above the interact on trigger component. Brilliant, all set? Then let's open up this script and take a look at the changes we need to make to it. Now, whilst we've not received any errors from Unity, with the way our script is currently set up, our health parameter's value won't change from the default value of 5 if the player interacts with the crate at low health. Now, this is because whilst we'll still be using the same function to set the value, that being set parameter by name, global parameters cannot be reached for an instance of an event. Remember, we need to treat them as if there's only ever one instance for us to use and for our events to share. So let's start by removing the line that uses the set parameter by name function from within our event instance variable to access the health parameter, which is this one here. Now, the way we must go about setting our global parameter is by using FMOD's Studio System object. And to understand what that is, we're going to need to understand a little bit more about how FMOD's API is structured. When it comes to the API that was installed into our Unity project when we first implemented our original FMOD package, there are two main layers at work. Now, the first is called the Core API, which before FMOD 2.0 was referred to as the low-level API. The Core API refers to all of the code written inside the script called FMOD that we looked at briefly during the namespaces lesson in Module 3. Because it is written using only the C# coding language, such as the basic data types, if and switch statements, and more, it is what forms the bedrock of both how FMOD works and how it can implement audio into other engines. To put it briefly, it handles all of the essentials of getting FMOD to play audio for us, such as selecting the correct sound card or audio device being used on our PC or console to play audio through, setting the maximum number of channels that can play audio at once, allocating our audio to memory, and even providing support to any plugins we may have installed into our FMOD project. Next is the Studio API. Now, the Studio API derives and uses the code found in the Core API to provide more functionality to do with the project we've created in FMOD and allows us to interact with it during runtime of our game. The code that makes up the Studio API can be found inside of the script called FMOD_studio that we also looked at in the namespaces lesson. This API allows us to create instances of our events, load in our banks, set up our buses, and more so that we can then start interacting with our specific FMOD project. It's also here where a lot of our original variables were declared, such as our event instance, event description, and bus variables. Now, to help myself understand how FMOD's API relates to both Unity and the scripts I write, I like to add two more kind of unofficial layers to the top of the Studio API and the overall hierarchy of the code. The first is the Runtime Manager and Runtime Utils layer. These are the scripts that use both the tools provided to them from FMOD's two APIs, as well as tools from Unity's API and Unity's engine, in order to provide further functionality for us to use in our scripts, saving us time hooking the two engines up together to work. For example, we can find many functions within this script that were declared by the Unity API. For example, if I search for the onDestroy function, I can find it here. To show you what I mean, take a look at this function created inside of the Runtime Manager. This is the attach instance to GameObject function that we've used throughout this course. Now, as we can see, this function is using a struct declared from within the Studio API script called fmod_studio. That struct would of course be the event instance struct, being used here as a parameter variable for the function. However, it's also using classes declared from within scripts built for the Unity engine. An example of this would be the transform class being used here as another parameter variable. We know that the transform class makes up the transform component. Now, this is a tool used so that we can set positions and rotations to various game objects in our scene. So where the two previous APIs, Core and Studio, relied solely on the C# coding language, Runtime Manager and Runtime Utils both used the material from Unity's API and the engine built from it. Finally, at the top of the hierarchy of code is the combination of all of the scripts that you've created combined. All of the tools created in the previously mentioned scripts were designed to be used to implement audio into a game, no matter what the design of the game might entail. But it's the scripts that you've been creating throughout this course that have taken those tools and applied them to be used in specific ways to suit the design of both the 3D game kit and the audio assets you've been implementing into it. Those scripts have also been able to derive and use information from all of the previously mentioned layers. For example, we've been using structs to form variables from the Studio API, such as the event instance struct. We've used functions from the Runtime Manager class, such as the play one shot attached function. And we've also referenced Unity classes, such as the transform and the rigid body classes. So how does all of this help us set our global parameter? Well, as mentioned, the Studio API is what handles a lot of data associated with setting up our specific FMOD project. Inside of it is something called the Studio System Object. Now, the Studio System Object is the main tool of the Studio API that allows us to interact with our project. The Studio Object does a lot of things, such as loading banks, fetching event descriptions, setting 3D attributes to any list of components in our game, and more. However, the only thing we need it for is to set the value of our global parameter. Now, what you're currently looking at now, you can think of as a template for creating a system object. Before we can interact with our global parameter through the system object, it first needs to be created and then initialized, or turned on to put it simply, using this template and the functions within it. You can see here both the create and the initialize function declared inside of the template of the Studio object that both need to be called in order for us to do this. Thankfully, we don't actually have to create the system object because the Runtime Manager will do it for us automatically. Now, if we scroll down, you can even see another setParameterByName function, which is what we will want to call. Now, inside the Runtime Manager, we can see a variable of the system type being declared and called Studio System. Now, there is a lot going on here inside the Runtime Manager in order to not only create and initialize a Studio System object, but to also make sure that only one instance of it can be created. So because of this, we're not going to spend too much time analyzing how this script goes about doing all of that. All we need to know is that if we use the Studio System variable in our script, we can interact with the Studio System object the Runtime Manager has created for us, and the many functions declared within it. So now that we understand where our global parameters are set from, it's time for us to edit our f_health crate script to do so. First, we'll want to replace our setParameterByName function declared within our event instance variable with the setParameterByName function that we found inside the Studio System object. Remember, the object was created inside the Runtime Manager class. So in order to access it inside of our onTrigger, enter, and if statements, we're going to need to write the namespace that the Runtime Manager uses, which is FMOD Unity, followed by the class name itself, Runtime Manager, then the name that the Studio System object was given, which if you'll remember was Studio System, and finally the function inside of it that we're after, which was setParameterByName. And if your script is already using the FMOD Unity namespace, like mine is at the top here, then you can go ahead and remove it from the beginning of this line. Now notice how, because the parameter is global and not local, we're not pulling the function from an event instance. So from here, we just need to feed this function the same arguments it would need if it was local. And as we know, the first argument it requires is string data telling the setParameterByName function the name of our parameter. Now normally, we'd either feed the name of our parameter as raw data into our function, or write it out manually into a string variable, feeding the variable to our function instead. However, because health is now global, FMOD provides us with a new attribute for us to access it with. So at the top of our class, let's create a new private string variable and call it parameter name. Then above it, we're going to include the serialize field attribute so that we can access this variable from within Unity's inspector tab, despite the fact that we've set it to private. And then on top of that, we'll create another new attribute and write the FMOD Unity namespace followed by paramRef. Again, if you're already using the FMOD Unity namespace, then you don't need to include it. Finally, we'll write the name of our new string variable as the first argument inside our function. So let's write its name, parameter name. So just like our other reference attributes, the parameter reference attribute works in exactly the same way. We simply save our script, go back into Unity, wait for the script to compile, find the object our script is attached to, and then we now not only have a box for us to enter our parameter name into, but we also have a nice search tool, making finding it a little bit easier. Now, if you try to do this now, you'll probably notice that the parameter name variable hasn't yet appeared, and that's simply because we haven't yet finished writing out our script. We still need to feed the setParameterByName function a second argument. So let's go ahead and do that now, which of course is a value that we want to set the parameter to. Now in my script, I did that originally by using the current hit points variable from inside the damageable class attached to the player character Ellen. And because I referenced that specific instance of the class inside the D variable, I now need to write inside of my function d.currentHitPoints. And that's pretty much it. We can now use the same parameter for all instances of our health crate event. So once you've done that, save your script, then go back into Unity, and don't forget to select the health parameter using the search tool. Okay, great. So now we can set global parameters by their name. But as we learnt in the last lesson, we might want to set this parameter by its ID instead. So how would we go about doing that? Well, for the health crate event, I probably wouldn't go to the trouble of setting the health parameter by its ID, simply because there are only 6 health crates placed throughout this game, and therefore the value of the health parameter is only ever going to be set 6 times by our script, which isn't very often. But in case you do find yourself needing to set a global parameter by its ID, this is how you would go about doing it. First, if you'll remember from the last lesson, in order for us to access our parameter's ID, we had to reference the parameter inside a parameter description variable. And in order to do that, we had to get the description from the event using the parameter. Well, we still need the parameter's description, but because this time the parameter is global, it's not tied to any one event instance, so we need to get it from the Studio System object. So let's once again quickly create ourselves a parameter description variable and a parameter ID variable. Next, inside the start function, we're going to write runtime manager dot studio system dot get parameter description by name. Feed this function the name of our parameter, and then output that parameter into our param description variable. Following that, we now want to set our param ID variable to the ID of the parameter we've stored inside of the parameter description variable. Finally, let's come down to our set parameter by name function, change it to set parameter by ID, and then replace the parameter name variable with the param ID variable. So notice that the key difference here is that just like how we use the set by name and ID functions declared within our Studio System object, we also get the parameters description through it too, because again, the parameter is not tied to a specific event instance as it's global. Now, because there is only one instance of the health parameter, we also only want one instance of each of our new variables. The way to fix this would be to make these variables static. So as you'll remember from our controlling audio between multiple scripts lesson, a static variable means that one value is shared. Essentially, there can only ever be one instance of these variables. And whilst we'll have an instance of this entire class for each health crate in our game, there will only ever be one instance of each variable shared between those instances of the class. This is because these variables are now tied to the original class that lives inside of our game's assets folder. So now that we have a single parameter description and parameter ID variable, we want to make sure that we only ever set their values once. Now, for each health crate that exists in each scene, we'll be creating an instance of our health crate script for them. So for the first level, that means there'll be 2, and for the second, there'll be 4. This means that the start function is going to run for each instance, and we don't want to initialize our new variables more than once at the start of our scene. So to fix this, we're going to create an if statement inside of the start function, and we're going to add these 2 lines of code to the body of that if statement. Now, before our game starts, the parameter description variable is going to be empty. Once one of our start functions is triggered and then sets our health parameter, we want to make sure that this doesn't happen again. So to do this, we'll check the name of the parameter stored inside of the parameter description variable. And if it isn't health, then we know that the variable has not been set yet, and we can run these lines of code. So let's write if param description dot name doesn't yet equal our parameter's name. If it turns out that parameter description dot name does equal our health parameter, then the variable has already been set by another start function, so therefore we won't need to run these lines of code a second time. To test that this has worked, we can add a debug.log function inside of our if statement, which is going to display a message once these lines have been run. We can also put another inside of an else statement, which will display a different message for each start function that doesn't need to set our variable. And then once we've done that, we can save our script. So now let's jump back into Unity and play our game. And there we go. Because we have 2 health crates in this scene, we can see one message for when our variable has been set and one for when it hasn't. If you only see one message, then make sure you have a copy of your health crate script attached to both health crate objects in this scene, and also make sure that for both of them, you've set the parameter name to health. And with that, you should now understand the difference between a local and a global parameter. Not only that, but you should now be able to implement a global parameter into your scripts, either by using its name or its ID. You might even have a better understanding of the multiple layers that make up FMOD's API, as well as how you can use functions from within the Studio System object. And with that, that's everything from this lesson. I hope you've been able to keep up with these lessons and understand everything quite clearly. And if, of course, you are still struggling and need more help, not only will there be links underneath this lesson to more resources for you to use, but you're more than welcome to get in contact with myself for additional help.